Hello everyone, welcome to my channel. In today's video, we're going to solve Leetcode problem number 994, that is rotting oranges. So basically, we are given a grid of m cross n where each cell have three values, which is 0 represents an empty cell, 1 represents a fresh orange, and 2 represent a rotting orange. And at every minute, a rotten orange can infect its adjacent fresh orange in all the four directions, right? That is upward, downward, the left side or right side. And our task is very simple, is to find the minimum number of minutes required to rot all the oranges. And if it is impossible, then we're going to return -1. So let's understand this problem first. So here we can see the complete rotting process. At minute 0, only one orange is rotten, right? And after 1 minute, all the fresh oranges which is directly connected to its become rotten, right? So those newly rotten oranges, this is the newly rotten oranges. Now it will going to try to rot their or adjacent oranges, right? So all the oranges that are rotten at the same minute, it will going to spread simultaneously, right? And this is the biggest hint that we should use for breadth first search, because BFS processes node level by level, right? You can think of it like each level as 1 minute. Level 0 means minute 0, or level 1 means minute 1, level 2 means minute 2, and so on, right? So the BFS perfectly matches the behavior of this problem, so that is why we're going to use BFS. Now, four directional traversal. Now let's understand how infection spreads. Suppose this orange present at position 0, 0, right? It spreads in four direction only. That is upward, then downward, then we have left direction, or we have right direction. The coordinate changes like up. Up means what? Up means row decreases by 1, right? So we're going to write over here minus. So we're going to traverse. Upward means we're just decreasing the row, right? Then down means what? Increasing the row, right? If we're going to move downward, we're just increasing the count of row. So that is why we get 1, 0. We'll just have to add this inside this position, right? Left means we are just decreasing by 1, which is 0, -1, right? And right means we are just increasing the column by 1, which is going to be 0, 1. And we're going to store these directions so that we're going to use inside our loop, right? And now let's see the intuition. Okay, now let's understand the BFS intuition. So this is our grid, and the rotten oranges is present at position 0, 0, 0, right? And fresh orange is going to be represented. Okay, the rotten orange is going to be represented by 2, right? It is given in the question. And the fresh oranges is going to be represented by 1, and empty cells are represented by 0. Right. So firstly, what we need to do is to just traverse the entire grid. And whenever we find a rotten orange, we just need to push it inside our queue. So initially the rotten orange is present at 0, 0. So we're going to push their coordinate inside our queue. So let's push this. So we're going to push it. We're going to add their coordinate, which is going to be 0, 0 inside our queue, right? And at the same time, we're also going to count the total number of fresh oranges present inside our grid. So we have 1, then 2, 3, 4, 5, 6. So we have total 6 fresh oranges that is initially present inside our grid. Right. So after scanning the grid, we know two things. That is, number one is where all rotten oranges are located. Right. We're just going to store their coordinate inside our queue. And number two is how many fresh oranges exist. So the question is why we are storing all the rotten oranges inside this queue. Because all the rotten orange is going to start spreading at the same time, right? Because this process is happening simultaneously. So the BFS should start from all the rotten oranges simultaneously, right? So this technique is called multi-source BFS. This is the new thing. Right, so this is called multi-source BFS. We are actually using multi-source BFS to solve this problem. So instead of just starting BFS from one node, we're going to start from multiple nodes. But according to this question, we just have one rotten node. So that is why I'm just adding their index inside this queue. Okay, now let's understand what happened inside this queue. Initially, the queue contained all the rotten oranges, right? And for example, here we have this 0, 0 orange, their coordinate. And we have fresh orange count, that is 6, right? So at minute 0, so we want one more variable. There we're going to store the minute. So at minute 0, I'm going to store it minute 0. Also, we want the count of rotten orange that is initially present inside of a queue. So for that, I'm going to take one more variable, that is, let's suppose I'm going to name them rotten. There we're going to store len of q. And until and unless the len of q is not equals to 0, we're just going to iterate it. So for that, for underscore in range, the rotten oranges that is present inside in our queue, we just need to iterate it, right? What I'm going to do, I'm going to take two in variables I comma j. Now here comes the main part. What we are going to do is we are just popping out the rotten orange coordinate, and we're going to store it inside our I comma j. We're going to compare it I comma j with their coordinate, right? So we just have to pop their coordinate. I'm going to pop him. I'm going to place it over here. So I is equals to 0 and j is equals to 0. So basically we get the coordinate of a rotten orange, right? And the next thing that we need to do is we just need to check their adjacent oranges, right? We have this is the rotten orange, so we need to find it their adjacent orange, and if the adjacent orange is fresh orange, then we need to rot that, right? So right now at position 0, 1, we have a fresh orange. So we need to rot that. So I'm going to rot this. And because this is a rotten orange, now this orange has become a rotten orange, right? So we know that we need to add it inside our queue. So we need to add their coordinate also inside our queue, because this orange is no more fresh orange. It's going to be rot now. So we're going to add it inside this queue. Okay, now this orange is also going to try to rot this orange, right? Because this is vertically downward direction. So right now this orange is also get rotted. Because this orange is rotted, so we need to add their coordinate as well inside our queue. So I'm going to add their coordinate inside their queue, which is going to be 1 comma 0. So basically we have 2 rotten orange inside our queue. And we also need to increment our minute. So at minute 1, we have 3 rotten oranges. So we're going to increment our minute. Now, again, we're going to pop left the rotten orange. So we're going to pop this orange. Basically, I'm going to pop this, just take out and place it over here. Now this time I is equals to 0 and j is equals to 1, means we have this position, right? If we're going to check, we have this position. Now whatever the adjacent oranges are there, and if they are fresh oranges, then we need to rot them. So we have 1 cross 1 comma 1 at 1 comma 1 position. We have a fresh orange. So now it will also going to rot. And at position 0 comma 2, we again have a fresh orange. So it will also going to rot. So because they are rotting now, so we're going to add their coordinate inside our queue, right? So I'm going to add their coordinate, which is going to be 0 comma 2. Now it will also going to rot 0 comma 2, and we have at position 1 comma 1, right? Because this orange is now also get rotted. So 1 comma 1, right? And because these are rotten, so we're going to cross them, because these oranges are no more fresh orange. Okay, now again we're going to pop the rotten orange from this queue. So we're going to pop their index, and now we get a new index. We're going to rub these indexes, and now we get, oh my god, okay, now we get the new index, which is this, right? So at I we have 1, at j we have 0. So 1 comma 0th position. So if you're going to check at this position, yeah, also we need to increment our minute, right? Basically, how many traversal we have done? I think 2. Okay, 2. Yes. So if you're going to check this orange, so at upward direction, the orange has already been rotten. At the right side, we have a rotten orange. Then at downward direction, we didn't have any orange, and we didn't have to move the left side, right? So nothing will happen. We're going to again pop the next rotten orange from our queue. So we're going to pop their coordinate. We're going to place it over here, and we just have to cross this. Okay, now at I we have 0, and at j we have 2. So 0 comma 2, this. So here also we can say nothing has happened, because the neighbor oranges are already been rotted, right? Okay, now again we're going to pop the coordinate of the rotten orange from our queue. So let's pop it out. And this time we have I equals to 1 and j is equals to 1, means this position. So this orange means this position, right? This position. So this orange we're going to try to rot this orange, which is present at 2 comma 1th position. So we need to add their position as well inside our queue. So I'm going to add this, which is going to be 2 comma 1, right? This orange is now also get rotted. And then again we need to pop the position of the rotten orange. So let's cut this, and now let's pop out the position of the rotten orange, which is 2 comma 1. Now j is equals to 2, and sorry, I is equals to 2 and j is equals to 1. Then we need to rot their adjacent oranges, which is this, which is present at 0,2. So now this oranges also get rotted, right? And this is how we need to do this. Okay, now let's understand the code first. So basically, initially, we know that we're going to calculate the row and we need to calculate the rows and column, and then we have grid copy equals to deep copy grid, which basically we are just creating to a separate copy of a grid so that all the updation will happen on this copied grid. Then we have a fresh count, initially is 0. So the fresh count, we're going to store how many fresh oranges are present. And this queue is basically a D queue, right? Store the position of our rotten oranges, right? Then we have, then we're going to visit all the cells of our matrix. So for that we have row and column, and initially we'll just combine them so that we're going to get the cell of our matrices. And now we have, if the grid copy of row column equals to 2 means if the oranges is already rotten, 2 means what? Rotten, right? So we're going to push its coordinate inside our queue, right? So we're just pushing their coordinate, right? Then after that, if we get a fresh orange, right? 1 means what? Fresh orange. So we're going to increase the count of fresh orange, right? So fresh count plus equals to 1. Then we have minute. Initially minute is going to be 0. Then while len of q not equals to 0 and fresh count greater than 0 means we're going to continue our BFS while q is not empty, right? And also our fresh oranges still exist. Then we have minute plus equals to 1. Why we did it so? Because we are just entering the next BFS level. So 1 minute going to be passes. Then total root equals to len of q, right? This is what I have done right now. Here I have just explained this, right? Okay, so total rotten equals to len of q. So this basically tells us how many rotten oranges are just present in, you can say, current minute, right? Okay, then we're going to again apply loop, right? We are just processing only the current level, right? So this ensures all the oranges spread simultaneously. Then we have I comma j equals to q dot pop left means what? And also means we are just popping the rooted orange coordinate and just we are just adding inside this I or j coordinate, right? We are just taking one rooted orange from the cube, right? Then we have for dx or dy in this whole. Basically, we are these are the coordinates, right? We are just checking there all the 4 neighboring cells. Then we have new I or new j equals to I plus dx or j plus dy. Means we are just finding all the neighboring cells. Right. Then we have some edge cases. These are the edge cases, right? If the neighbors is out of the grid, right? If these are the condition, if the neighbors are out of the grid, so we are just going to simply skip that iteration. And if the grid is going to be empty, right? Or if we have a rotten orange, so there is no sense to add those oranges, right? So we're just going to skip that iteration too, right? And then after that, we're going to decrement our fresh count, right? So one fresh orange has become rotten, so we're just simply going to decrease the fresh count. and also we are just converting the fresh orange into rotten orange. So newly indexes is going to be converted into rotten orange, and then we're just going to add the newly rotten orange inside our queue, right? And if the BFS finishes, but still we have a fresh oranges remain, so they are basically unreachable, right? So in that case, we are going to return -1. And if all the fresh oranges become rotten, so in that case, we are just simply going to return the minutes, right? So the key idea of this problem is basically multi-source BFS, right? Where we have all the rotten oranges are inserted into the queue initially, and each BFS level represents 1 minute basically, and every newly rotten oranges become the part of our next BFS level. So basically, I do have written all the codes, and let's run this code. And let's submit this code. Okay, so that's why the BFS is perfect solution for this rotting oranges. And if this explanation helped you to understand the intuition, so don't forget to like this video and subscribe to my channel. And I'm going to see you in the next video.